Hi guys, so welcome to the LoRA training video. Today we're going to go over how to train a LoRA using civit.ai. I might make a future video to show how to create a LoRA using Koya, which is just a built-in web UI that's run locally. So it's maybe a little bit more private and the cost is lower or free, just your own computing power. But today we're going to use civit.ai, so it does cost a little bit, typically between like 50 cents and $2 per model, and you just buy credits on the civit.ai website to do that, just using your credit card or PayPal account. And I think it's the interface is a little easier and the cost isn't so bad, so most of the time that's what I've been using. To run these things, and it lets me run it on the civit.ai servers so that I'm not using the computing power on my machine, and I can continue to use my machine for other things while it loads or while it trains. So let's get started and go to civit.ai. Make sure you create an account, and then once you've done that, go to train a LoRA. We're going to train on images, and we're doing a stylistic LoRA. And today I'm going to be training a LoRA on my own images. So one thing to note before we get started here is that to train a LoRA, typically the sources that I've seen say you should have at least 20 images. And typically they are in a similar style and similar perspective. So if I want to train a LoRA on a collage style for a perspective rendering of a piece of architecture, then I would have 20 images in that style and as close to that perspective as I can. If I want to produce a LoRA that specializes in a hyper-realistic rendering style in aerial view, then I would have at least 20 images that meet both of those criteria. Today I'm going to do something a little bit different. I'm going to train it on a data set of my own images that I've produced over the last year, and I don't have 20 images that are in a similar rendering style and perspective, and so I'm going to put in 27 images all in sort of different perspectives, styles, and even some line drawings, some section drawings. And this is typically not what you would do. Like I said, you would stick to, if you want to train it on section drawings, you'll train all on section drawings. But I'm curious about what will happen here and if the results will be any good. And I'm also curious about, I want to train one of my own images. So we're going to give this a go here. And we're going to take all of these images and drag them over into, okay, images should not exceed 50 megabytes. So I've got a bit of a size problem here. I have 26, so I can delete a few. What's this one? So I'm going to delete that one. And let's see, that should work. Yep, okay. And so when you're working in civit.ai, it's going to ask for a trigger word. This is optional. I usually don't add a trigger word. It just means a word that you can use in the prompt that calls the LoRA. We don't really need that because we can just click the LoRA button at the end of the prompt. And now we have to go through and tag these images, which is kind of a lengthy process. So what I've been doing is I've been using Claude to do that. So my input is limited to 20 images, but I'm just going to say, give me image tags for these images in order to train a style LoRA in civit.ai. And then I will grab 20 of my images and drop them in. Because it only takes 20 at a time, so then I'll have to come in and drop the remaining 5 in after I've done this. You can tag manually. I've done it before. It just takes a bit longer. And one thing to mention here is I won't be tagging anything about the style of the images. I won't be saying collaged or anything like that. I will simply be describing what appears in the scene. The purpose of the style LoRA is to learn the style of the input dataset and to be able to reproduce it without that style being described to it, being prompted. And so by describing the quality of the image in the tags, it kind of defeats the purpose of the style LoRA, is my understanding. So we're just gonna, if Claude gives us any, collage or line drawing kind of words, we're just gonna delete those because I don't want to have to prompt those words every time I want to use this LoRA to produce something. If I were to prompt that, then it would require me to use that kind of language when I use the LoRA. We will describe the scenes, we'll describe what kind of objects are in the scene, and we'll describe the perspective of it, and we'll go from there. So it's going to give me these back in kind of a strange order. But what I'm going to do is just copy my tags in. I'll show you the first 2, and then after that I'll speed through this part of the video. Okay, so I've finished tagging everything. As you saw, I removed the 3 section drawings because I realized they might skew the LoRA a bit too much, and I could afford to get rid of them and still have more than 20 images. So when you're doing this, one thing I forgot to mention is you can do the tag or caption options. And so with tag, it's like a comma delineated way to tag the images. So it's preferred for SD1 and SDXL models, and then this label type is preferred for Flux, SD3, and video models. So I went with the tag because I typically use the SD1 and SDXL models. I own the rights to the files. I don't want to share the dataset, and I confirm the legal statement, and then we hit next. And on the next page, it's going to ask me for the training parameters that I want to use. And so I'm going to ask Claude what training parameters are recommended. Okay, so here we are at the next screen after the tagging, and we'll train for the SDXL model. We have an option of what to train for here. We'll do standard XDSL. You can click through these and see what it suggests their uses for, but let's stick with standard XGSL. And then sample media prompts, I'm going to go back into Claude. Give me 3 sample prompts for training this data set to see sample results. Okay. And so these will be, when civit.ai shows you your results for the LoRA training, it'll be producing images using the LoRA that adhere to these prompts. So this is what you'll be seeing. And now let's see what Claude suggested for the training. So with epochs 10 to 15, I like to go on the high side. So the epochs is, it says here, an epoch is one set of learning. By default, we will save a maximum of 20 epochs, evenly distributed, and they are all available for download. So basically it's a training iteration. Sometimes the 10th one is the best, sometimes the 5th one is the best. It just depends on what style you're going for. And sometimes you can have like an overfitting to the data, so you've trained it too much and it starts it's a diminishing return, so the image quality starts to go down in the higher epochs. That sometimes happens. I think 15 is good for this. Number of repeats, let's see, what did it suggest? So I didn't actually get that, so I'm just going to copy these parameters into Claude and say suggest best parameters in this order. Okay, epochs 12, repeats 10, batch size 1, resolution 1024, standard LoRA. We do want to shuffle the tags. Keep tokens. This is, if you're training images have tags, you can randomly shuffle them and keep the tokens. So these will be tags that are kept when all the other tags are shuffled. The clip skip, so it tells you here that for anime use 2, everything else use 1, so we're going to use 1 because this is architecture, not anime. Flip augmentation, this means that you're going to, the image will reorient. That's very, the orientation is important for architecture, so no, we're not doing that. UNet learning rate, there's 2 learning rates here. One is typically half of the other, so the text encoder is half of the UNet. I've only ever used cosine with restarts on the learning rate scheduler. I feel like that's always been the best, even though I don't really know what it means. Learning rate scheduler cycles 3, 5, suggesting a network dimension of 48. Network alpha is half of that, so 24. Noise offset 0.0357, 0.0357. Okay, so I can't type in the 57. I'm going to go with 03. And it's suggesting the optimizer to use Atom W8-bit. I've never had good results with Atom W8-bit. I've only had really good results with Ada Factor. I think this one starts to overfit too quickly or something. I'm not sure. Optimizer args, we can't change that, so I'm just going to leave it blank. And it's giving some justification for what it chose. High priority, I guess if you want it done quickly, that's great. And it gives you an estimated time here. So it'll take about 2.5 hours to train this. My cost is 1,000 buzz, which is like, I think $1. $2 or something. And so this all looks good. I'm going to submit and start training. So you'll see we have it in the queue, it will submit, and it'll show you updates on how it's moving along. There's a disclaimer here that says trainings aren't always successful, da 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 da. I've never had one fail, and I've never had one take more than like 5 hours. So I'll check back in when this is done and we can give it a try in Stable Diffusion. Hey guys, so our LoRA model just finished up and you can see it here. It says ready, so we'll click on it. And on this screen, I'll maximize this. On this screen, you can see how it generated the different prompts. I'm going to zoom in a little bit. Okay. So you can see how these are all sort of a different quality. This one actually looks really good. So is this. See, sometimes the earlier epochs will look better. So it's doing this section pretty nicely. You can see in the earlier epochs, like the lines will be a little less coherent connecting things, although sometimes I'm really surprised by how things look. So a lot of times what I'll do is just download a few of these and see which one is working the best and try a few of them out. So that's what I'll do here. Okay, so let's scroll through and see which ones we want to download and try out. Actually, I think this one looks pretty good. So I'll download that. So we've got Epoch 10. And let's see. I really like how it's doing this section over here, so I'll probably give it that kind of prompt. These look a little bit too crude. And so I'll just do that one and I'll do Epoch 15 just to see what the latest looks like. That'll take a minute to download. And then I'll show you guys how to add it to the folder so that it shows up in Automatic 1111. Okay, now that these are downloaded, I can go into where they're downloaded. It'll be a save tensors file. So I've got 2 here. And I'll just copy those and go into my installation of Automatic 1111. Excuse me. Go into models, LoRA, and just paste them in there. Okay. And that's it. We'll close that. And then we can open the web UI. Okay, so now I'm back in Stable Diffusion and I've uploaded a new sketch in the text to image tab just to try this out. Feel free to use whatever workflow you want, obviously, when you're trying out your LoRA to see what the results look like, see if you might need to retrain, maybe run more epochs or increase the size of your data set. I'm really not sure how this is going to come out for me because I did use such a wide variety of image styles. I more just wanted to show you the steps in the process. So I've started to type a prompt here, and I'm using the Juggernaut XL, so I'm using the Canny XL. So I'm just going to go back into civit.ai. If you want to see the LoRAs that you've trained already, click on your profile tab, go to training. And let's go look at this one to see what kind of words we're using in the prompts. ArcViz style, axonometric section, industrial warehouse exterior. Okay, 3D render, contemporary, corrugated metal. Okay, so let's go back into stable diffusion, and let's just kind of copy some of those words. I'm happy with my prompt, and let's put in the LoRA that we just trained. I will negative prompt people and cars, and let's just adjust our parameters here for better image quality. If you're not sure what these are, go back and watch the other videos. They explain how to tweak all these parameters and what is best for what purposes. And let's generate that. Okay guys, here's some results from that run. Looks pretty cool. Tell you what I'm gonna do. I'm gonna put in a few more drawings and just show you guys the results at the end.